C language has a inbuilt operators. Operators basically perform the operations on operands. We know that, right? Operators, which we use for actually manipulating the data and then variable content, right? So that is what I think today's topic. Welcome, guys. Thanks for joining. Welcome to Maths Bridge. We shall continue our C programming learning. Okay, we are actually part of a slogan called a train and learn. We train, you will get an opportunity to learn. Okay, without further delay, let's get started. Folks, please do visit us at our YouTube channel Maths Bridge. I'm sure I think you are already subscribed to the channel. If you have not, please do subscribe the channel and then support us. Thank you and then happy learning. Here is our today's agenda. Precisely speaking, C programming is widely used in embedded systems. So the people the professionals who are working in embedded systems or hardware related, the work for them, C programming and then bitwise operation are very important. The people who are working in a microcontroller, microprocessor and reading the input output, the pins, those folks, for them this concept is very important. That is the one reason where bitwise operator introduced in C programming. For this is a basic building concept for them. Okay, let me get you through. So what are all we have in the bitwise operation? So we have a binary and bitwise AND operation, bitwise OR operation, bitwise XOR operation, complementary, and left shift and right shift. Okay, basically this operates on each bit. We know, though we are representing a whole number, but when comes to the computer only works on binary values like 1 0 0 1 kind of a stream. So this operation works on each bit, rather actually talking about a whole number. Okay, let me show you the few examples to understand the concept. So I hope we all know that like a number system, we have a decimal number system, hexadecimal number system, binary, octa and all, right? So for instance, I am taking like a three number systems for our concept illustration. So when I say decimal, like we know the numbers like a 0 1 2 3 4 5 6 7 and so on, right? I have noted here like 16 level. Okay, hexadecimal representation for each of these decimals are like 0x0, 0x1, 2, 3, 4, 5, 6, 7, 8, 9. Instead of 10, now I'm getting like a 0a, because equivalent of 10 in hexadecimal is like A, equivalent of 11 is B, C, D, E, F. So if somebody says like hexadecimal F means that is a decimal equivalent of 15. Now the question is like how we are going to represent them in the binary. This is a binary representation for all these numbers. Okay, 0 means all zeros, 1 means like 1, 2 means like a 0 0 1 0, 3 means like a 0 0 1 1, and so on. F means all ones, 1 1 1. Okay, this table that we are going to take it as a lookup table for understanding a concept. Okay, now what I would do, look at this simple example. Num1 I'm holding like a 15, num2 I'm holding like a 10. Then the ask is what's the output of bitwise AND operation. If when I say AND operation, we require two inputs like a num1 and num2, and then bitwise AND with, right, then produce the output. Any guesses how you can actually solve this problem? So let me pick my pencil and then let me draw it. Where are we? Okay, we are here. So when I say num1, right, is 15, what is the equivalent of binary for this one? So 15 means like this. So the value of binary is like all ones, 1 1 1 and 1. Now num2 you can take it. Num2, how much value? 10. So how do you represent 10 in binary? 10 in binary is this much, right? What that value? 1 0 1 0. So now what you will do, like you will operate operation on bits. What do you say is like a AND operation, right? AND means like this one. So if you look at the truth table, if any one of the input is 0, then output becomes 0. That's what it means. 0 0, right? 0 0 means 0. 0 1, logic 0, logic 1, because 0, right? And 1 0 0. So output will become like a 1 when both inputs are 1. That's an operation, right? Now you just apply this rule here. Okay, 1 0, 1 0 bitwise AND operation becomes like a 0. Agree? 1 1 becomes 1 because that's the last step, right? 1 0 again 0. 1 1 becomes 1. So this is what you are going to get a output of and bitwise AND operation for num1 and num2. Okay, what's the value? Equivalent of hexadecimal or binary 1010. Can you see here? 1010. So this same only 10. Okay, so the output is 10. So that means when you say like num1 bitwise num2, okay, uh, it produces the output is called 10, which is what the explanation. Let's see how this works in programmatically. See the same problem statement. Now I wrote it as a program. Int num1 is 15, int num2 is 10, and then I did like in a bitwise AND operation, and it returns a value and I'm trying to print the value. So 15 bitwise AND with 10 becomes like a 10. Do you see this one? This is what exactly we also got it theoretically. You might had a question inside. Why would I need to really study the bitwise operations? Right? It sounds to me like a little bit of complication. It is a it is not really complicated, but if it is complicated, if you theoretically try to understand how it works, but programmatically is straight simple because all you have to understand is syntactically, what are all things that you have to use to do this bitwise operation. But understanding the concept is definitely helps you to love the subject better. Okay, let me tell you one simple application. So somebody is saying that how to clear bit 0 of num1. I'm holding a num1 is like a 15, but the ask is like can you clear only bit 0? So how do you do that? Okay, so the simple way to think about is what we are saying is here 15, right? 15 means 15 means how much? 1 1 1 1. What the ask is like you have to clear this value. So means like you are expecting output should be produced as a 1 1 1 0. That's what the ask. So then what is the value that I have to use? What operation that I am going to do this, right? So in order to clear this bit, all I have to do is like I have to multiply by 0, multiply with 0, right? I don't want to touch these things. So what I would do, I have to choose 1 1 1, right, and 0, and then bitwise AND operation. This would becomes bitwise AND, right? If I put a bitwise and, now you see 1 and 0 become 0, 1 1 1, 1 1 means a 1, 1 1 means 1. This is a truth table again. Clear? So without touching all other bits, if I wanted to clear the the last bit, least significant bit, this is what mechanism that I have to choose. 1 1 1 0. What this means? This means 14, right? 0e value. So the answer is num1 equal to num1 bitwise and with 0e. If you can write this, then it clears least significant bit. That's what you wanted. Do you see? This is a kind of like an application that you can come across when you work on like a hardware. We discussed this in previous class. This is like a truth table for the NOT operation, truth table for the AND operation, truth table for OR operation. Okay. One more sample program which illustrates all the bitwise operations. So here I am taking like a 3 numbers and I'm doing like in a bitwise AND, bitwise OR, exclusive OR, XOR, and then left shift and right shift. I think these are the important. When you actually do like a left shift by 1 bit, that means like the given number multiplied by 2, right? If you do like a right shift by 1, that means like given number divided by 2. That is how it works. Okay, so multiplication division can be achieved by left shift and right shift operations, bitwise operations. Okay, complement is another way. A complement means like 1 become 0, 0 become 1. That's what a complement means. You try, you do like in a sample programs, then you will understand how it works. Let me take you through my demo. Look at my screen now. I have displaying a sample program here. Okay, what I'm seeing here is that I have a number 1, number 2 loaded with like a 0f hexadecimal value 0a. We know bitwise AND operation, so this is like a symbol for the bitwise AND. So when we do it, bitwise AND means like it operates on the bits, and then AND means like a, if the both inputs are 1, then output would become like 1. So with which what we have seen in the discussion, that bitwise operation of num1 and num2 becomes like a 0a is an output. So let's see like what it produces. Okay, let me compile this code. Okay, I need a main, so compile and run it. Do you see this? Excellent. So we got a. The reason I'm actually displaying here line number 12 and 14 both are same except the format specifier. If I put a like hexadecimal, X as a uppercase letter, then I would get like A as an uppercase. If I get like if I put like a lowercase x, then I would get like a lowercase a. That's only difference. Otherwise, this is how bitwise AND operation on two operands works. Okay, now going back to my second example, do you see this one? What it says is OR operation. We know OR bitwise OR operation. OR means like if we either input is 1, then output become 1. So but now we are operating with the bits. I have hexadecimal value 1 0 and 1 1. So 0 1, if you put like in a bitwise OR, it means like adding number 1 0 logic 1 and logic 0 becomes logic 1. 1 1 logic 1 becomes like a logic 1. So the output would be 1 1. Agree? So let's compile this and then see what would be the output. Great. So bitwise OR becomes like a 1 1. Is it clear? Very nice. Thank you. So now let's look at a third example. In third example, what we are doing is like shift, left shift and right shift. You all must have to remember one thing, that when we left shift by 1, that means like the given number multiplied by 2 is what you get an output. Okay, if number right shift by 1 means like a division operation. How many times you do shift, those many times you have to do math with 2. Like if it is a left shift by 2 means like twice you have to multiply by 2. If it is a right shift by 2 means then you have to do divided by 2 twice. That is how it should work. So let me get you through, compile and run this program and then see that output. Do you see this one? Okay, left shift by 1 means number what we get is 30. So what is given is like 15 left shift, 15 times 2 is 30. That is what we got it. Very nice. Now look at right shift by 2. What happens? I have 10 right shift by 2, like for one shift we are divided by 2. 10 divided by 2 is like 5. The 5 again we have to divide it by 2, right? So 5 divided by 2 becomes like 2. The coefficient is 2, remainder is 1, but we are only taking nth coefficient value. So that is how left shift and right shift operations we use with bitwise for multiplications and division. Clear? Now go back to my the other example. So I would save this one, go to the fourth one. Do you see what this one is? A complement. Complement means like for a given number you flip it. 1 becomes 0, 0 becomes 1. That's short. Let's say for a given number is like hexadecimal 00FF. What it will do, if you operate a complement like this, negate, then 0 become F become 0. That's what you should supposed to get it. Okay, let me compile and run this program. Do you see? So 00FF becomes FF00. This is called a complement. Okay, you are flipping the bits. 0 become 1, toggling the bits, you mean to say. Because this is how the bitwise operations are working. So it's very easy to understand, and it's very practically bitwise operates plays a very vital role in embedded system, precisely. Thanks for watching. Please like, share, subscribe, click on bell icon and leave the comments. Happy learning. Thank you. Stay tuned to upcoming sessions.